Cool. I thought I'd do my fortnightly jump into your agenda and try to drop you all updates on what we're doing for observability. So happy to take discussion on things, but it was also just trying to do that, like give you all the view. I know Matt and Stephanie, you're already working with Nick, so nothing's a surprise there. But I was just trying to drop in like what we are doing. Like we are getting our third team member in October, but I've just got Nick and Calliope working on things. But we're trying to kind of work in parallel a little bit right now, and both efforts with you all, just different pieces of scalability. So Nick is focused on trying to help with everything we're trying to do for Thanos ruler stuff, and focused on that. And I, linked that epic. I think it's pretty clear because it's a sub epic of everything you all are doing. So it's really just trying to enable everything there. I think there are some hurdles Nick is trying to figure out about how we shoehorn making the Bitnami chart work for us as we add more tenants. So there's discussion there around like how we're going to scale this thing in the future without having to make the way we apply the changes in Helm too hacky. So he's been letting me know about that. We're thinking about things there. And then after a conversation with Liam yesterday, really trying to prove out more on Loki on the POC that we had going, and Runway seems like a good way to be working with right from the start. So I just talked with Calliope and with Liam about let's start getting a vision of like how we ship logs to Loki right from the start from Runway. So we're trying to work on that. And the other thing is we just got kind of the initial green light to do a proof of value exercise with Grafana Cloud to try to assess, is the future us self-hosting Loki? Is the future us using hosted Loki from Grafana Labs? So we're evaluating that because the initial bar park quote for what we could do with Grafana Labs is coming in under what we currently spend on Elastic, which is intriguing. So we're going to do a proof of value exercise, and I'm working through the compliance pieces, but it's basically thinking of trying to turn on the fire hose to Grafana Cloud for like 2 weeks of production logs and see if they can handle the load and if our estimates of log volumes are right, and what value could we potentially get out of that. So we're going to work on that. And then Calliope actually pointed out a good point to me, like when we do that, we could probably do the same thing for our own self-hosted Loki and prove that we can scale self-hosted and give us 2 weeks worth of log data, just kind of look at and see worth some value on that. So there's work on that. Another piece of that is actually also writing up a more clear business case of why we're thinking of seriously switching the log backend to that. So there's work coming out of that in August, September on those things. That was a lot of talking, just kind of the general stuff on the bullet points, but I see you typing something, Andrew. So I don't know if you wanted to cover something else.
The first thing I just was putting in there is that a friend of mine's like a tech lead on Loki Cloud, and I didn't realize that we were actually considering that. I thought we were just going to go purely self-managed. And so he was happy to have like a little tech session. Like he's invited me to several sessions in the past, and he's reached out and he said, I owe you a favor. So whenever you're gonna start considering Loki, please ping me, please ping me.
Well, I just
was like, wait a minute, I don't want to get in the way of the sales guys. And I said to
no,
him, oh, don't worry, self-managed.
Yeah. Well, no, and it literally like two different things have happened. Like actually one of the other directors of engineering at Grafana is a friend of mine from days back when I was at Rally. So yeah. I know people there too. And yeah, they've tried to stay out of the way, but I literally just did a presentation with Alan yesterday with the salespeople to say like, hey, this is what we see as the potential proof of value. Here's the ballpark figure they think that they could come in at. Now that we know that, it is like, okay, yes, we do want to go ahead with the proof of value, but that decision was just made yesterday. So I need to share all that information. So yeah, no, thank you for letting me know.
I'll just keep that. I'll just figure out what's going on with that first, and then because he doesn't want to step on like the sales guy's toes or anything like that.
No, I think
we'll convince him to use self-managed. God forbid.
Well, no, I think the other piece of what the proof of value exercise will help us learn is we're interested we know, I mean, you naturally know like cost is going to be less if we decide to self-host OSS Loki. But what we're kind of interested to also see is by going enterprise and clouds, like are there other features that we would get of like a little
Yeah.
a little observability team, the tenant provisioning experience, and the ability to create like basically log budgets of like you can send a terabyte a day of logs and then we stop you there, we'll warn you.
Yeah.
Like if there's features like that that they've got built in with the enterprise that are going to save us time and have useful features from the start, we're interested in seeing what that value lift is. So again, that's part of the proof of value exercise.
Cool. No, I mean, I think that's a good idea. The only thing I would say, so we spoke about this in the runway demo this morning about the runway kind of low key, how they kind of, and the thing that we were discussing was that from the runway point of view, we don't really, or the runway team don't really mind however this is done, but we cannot have it that those two things become dependent on one another either way, right? So like really from the point of view of runway, they, if at the moment it's using Elasticsearch and that's emitting to that, and then you bring in Loki before runway goes like GA, then we'll use that. But also at the same time, like if that's delayed or whatever, like from a risk point of view, we want to make sure that that we'll just go with Elasticsearch then. So we're not going to have any and I'm a massive fan of Loki. Like I want it, but I don't want to couple those two projects together where like a delay on the one project ends up like affecting.
No, yeah. So my attitude is that we would
and,
use the OSS self-hosted Loki because the play for Loki for Grafana Cloud is longer because we have Elastic credits through April. So, but basically, if we're just shipping to our self-managed Loki, we're already planning. That was already in our OKRs to be like, this is what we're planning to use. This was just the due diligence of like, if I can get a vendor to do it, we'll think about it. But that's
what was spoken about in the call this morning, which kind of allayed some of my fears, was that the Loki is going to kind of be tapped from the point of the pub sub. So it'll basically, so like really from the application point of view, we're not changing anything. It's just emitting to a topic. And then either that, on the back end of that, either it's going to Elasticsearch or it's going to
correct.
Loki.
Yeah, I think that may be the right architecture to keep it simple. But either way,
but
we want to make
it's
we
not
want to
like
make the experience super simple. Like here's
to
the
give an example of what
into
I just sorry to give an example of what would be more worrying is like if we wired like the Loki sender, like log sender, like directly into the containers in the application in runway, and then and that was like all wired in right from the start there, and then we didn't have the backend ready, and we were saying no, we can't go live because the backend's not ready for it was an unexpected thing or whatever. But at least if it's kind of hooked in at the pub sub point, we can say, well, we're just going to go with Elastic Cloud for the first 2 weeks, and then when you're ready, we can switch over on the pub sub. So I don't know if that's something that kind of works for you.
That's what, I think we need to decide on exactly what that architecture is, Andrew. The back end is ready. I mean, we're ready to provision a tenant for you and, we would configure Promtail to just ship directly to Loki. But I do see what your point is. I think we just need to make the decision on what that architecture is that gives us the right flexibility.
Because obviously, there's a whole stack of, so, runway on itself isn't that important, but then on top of runway is like AI gateway. And if we go live with all fresh stuff that's got no logs all of a sudden, there's going to be like a lot of eyeballs on it. So we've just got to make sure like that risk, runway on itself is like medium risk, but then like there's stuff on
the
top
apps
of
on top of runway are bigger. Yeah.
Yeah.
I had two other questions related to that. One was just a dumb one because I hadn't been able to check in with y'all in a while. Where's code suggestions going to live in the long run? Is it going to stay in its own intermediate project, or is it going to .com or Runway?
It's in a project called Model Gateway.
Yeah.
Model Gateway is what it's always been. That project is the same project, but it will be renamed to AI Gateway. And then at the moment, it's running inside its own Kubernetes cluster. Yeah. And it will migrate to a Runway app, if that makes sense.
Okay. So eventually it is moving to the Runway app.
Yeah. And that's where the risk around logging and all of that becomes, like we've got to have those logs and, all of that. So, I mean, I would suggest, even if we go live with Loki, I would suggest that maybe we go live with Loki and Elastic for that,
in parallel.
just to kind of have like less stress if things break and
Yeah,
people are going,
that makes sense.
dogs,
No, and that's
because
why we wanted to kind of make sure we're talking about this, because I think it is making sure we understand the requirements are. But that was in the case of who's working on what. It was trying to say where the team is focused on that, but like basically doing what we need to do for Loki, and apparently, like making sure the logs ship okay for Runway is one focus, and the other focus was doing the Thanatos ruler work. Those are the two things we've got in flight. Where all of our focus is. I think the other thing I picked up with Liam, just to make sure I round the other, and this was the other thing I was going to say, was also just making sure we prove out a good experience in Grafana for them to build their dashboards, because part of the reason Code Suggestions built their dashboards in Kibana is because we gave them the flexibility to do so. But I do understand from conversation with Igor yesterday, like part of, not Igor, with Liam yesterday, but Liam was telling me Igor was uncomfortable because on the other hand, they built their whole dashboard that Code Suggestions has, but it's in Kibana. It's not in source control anywhere. So
that's another reason. That's another really good reason to actually ship to both until we are able to, to gradually migrate, just from a risk management point of view.
Yeah,
because that stuff goes into AI strategy meeting, for example, and it goes into they're looking at that to make decisions around the GA decision on Code Suggestions. And so if that all falls apart, then there's going to be
so that, but anyway, like I heard that sense of like we need to go make sure we prove out that experience of like, okay, if we're shipping data into Loki and you can build your entire dashboard in Grafana, we just need to make sure that experience for how they build that dashboard, it's saved in, with the way we build dashboards and runbooks and things, and that's actually saved as code, and actually, but also fairly easily editable when they want to do like proofs of concepts on their dashboard and then say, okay, now I want to save it. Like we'll need to make that experience.
Having an overlap period, I think, like where we're running both, might be pretty helpful for that as well.
Cool. All right, that answers my questions. Thank you for letting me steal a bunch of your time. Chance, I want to make sure I give you an opportunity to do your demo. So
yeah, no worries. That's probably a great segue into the next topic. So I've been working on observability for Project Runway, specifically metrics, and I wanted to demo today a topic that might be interesting to other folks here, the Prometheus agent, which is kind of a less known aspect of Prometheus and Thanatos remote write. And so let me kind of get started with that. Do a screen share here. Okay. Can everyone see my screen? Looks good. So just to recap, Runway is built on top of Cloud Run, which is Google's kind of managed Kubernetes as a service. What this looks like is it's typically spins up an ingress container to serve web traffic essentially to the application. So it's really good for like stateless applications. And every service in Runway fully integrates kind of with the GCP suite. So it ships automatically with metrics out of the box here. So it includes kind of the metrics that are incredibly valuable that we're interested in here, like request count, request latencies, container utilization for CPU, memory, etc. We're generally interested in these types of metrics here. But this is what's like a solved problem, right? So this exists right now. There is the Stackdriver exporter. So we have experience like kind of running this, I think, in like various different places, right? Where we essentially go out and fetch these metrics from Stackdriver API, kind of pull them into our Prometheus instances here. The reason we're interested in these metrics is because once we kind of set up this Stackdriver exporter, we're intending to use this for default SLIs and SLOs out of the box for every Runway service. So essentially, all services that are on Runway will get default service overview dashboard, default SLIs, SLOs out of the box for that. So that's kind of what we're calling default metrics. That's actually not what I'm going to demo today, because as I mentioned, that's kind of a solvable problem, and we have a clear plan for that. What I'm going to demo today is custom metrics. So first, kind of the reason why I'm going to do that is just to recap about the Pareto principle, right? So 80% of Runway users are going to be satisfied with these default metrics that are going to ship out of the box. It just so happens that the first service that we're migrating to production, Code Suggestions, falls into that 20% of their heavily users of custom metrics. It's custom instrumentation littered all throughout their application. So it's kind of a deal similar to the Kibana dashboard. It's kind of a deal breaker for us to migrate over the model gateway without breaking their existing custom instrumentation that's all set up throughout the application. So what we've so it's a little bit more of a trickier challenge to solve. So you typically don't want to expose a metrics endpoint publicly, because that can include personal information. So a solution that we've kind of come up with here is leveraging a few different kind of experimental features. So the first is sidecar containers in Runway. So what this looks like is, in addition to the ingress container that all services get spun up, you can also spin up up to 10 additional sidecar containers. So we spin up, we're providing an option to spin up a Prometheus agent sidecar. And so the Prometheus, it's not the entire comprehensive version of Prometheus, but agent mode is like a lighter weight version. So you think about, like with Prometheus, it's a pool-based architecture. There's the push gateway, but that's primarily used for batch jobs, right? So you don't want to misuse that. And then a few years ago, they kind of came out with the Prometheus agent, which is a way to essentially scrape. It's very limited in the feature set that it just simply scrapes endpoints, scrapes targets, and then remotes writes that data to some source, some central source, right? So in our case, it's Thanos receive. It can be some type of cloud provider, etc. And this is kind of like what this looks like when you boot this up. It still is technically considered an experimental mode agent. Yeah, it kind of fires up, and you can see it configures with the remote write, startup probe, it succeeds, etc. And then it's like ready to start scraping the targets essentially. So I've created a simple kind of web application here that just serves requests. And when a query parameter is present, what it will do is just kind of increment a counter, a custom metric counter, if you will. So let's do that. Click that a couple times, jump over. You'll notice that the slash metrics endpoint, of course, as I said, it's not public. We wouldn't want this to be publicly exposed. So the web application can't actually even serve that, right? So then what we'll do is we'll jump over to Thanos. I will give a disclaimer to kind of just to the demo gods. Thanos staging receiver is a little sporadic. I've kind of been bugging Nick about it. So let's see if this works here. Okay, and it worked. So you can see that I've called this the Runway exporter, and you can see that the labels are there. So that custom metric is being scraped from the sidecar. So just kind of recap the architecture here. This is entirely optional, but we have the ingress container that's being spun up with the Prometheus agent sidecar, which is then configured to scrape the ingress container at a metrics port that it chooses here. So then we're able to kind of get that data in. We, of course, obviously still have to work on label parity, etc. But this is kind of the way that the custom metrics continuity will continue to exist. So I can kind of briefly show you what this looks like from opting in perspective. So as I mentioned, this is most Runway users are probably not going to need this, right? Like they're going to be satisfied with that 80% default metrics case, but we need to ensure that things continue to work for Code Suggestions, right? We don't want to discourage them using custom instrumentation. So this is going to be more of like an opt-in feature, if you will. But the way that this would work is in our runway.yaml, which we call sometimes a service manifest. You could essentially provide a list of like scrape targets here. And you would do this on the ports that you are spinning up as processes within your Docker image container. That's your ingress container, right? So not publicly exposed endpoint. The reason this doesn't use like service discovery or anything like that is just because you're only going to have so many metric processes that you're spinning up essentially. And then what we do is we take this scrape targets, and we basically configure a dynamic Prometheus agent configuration. As I mentioned, it's much more concise configuration for Prometheus. It's just discovery, scrape, and remote write. And you'll see that that's where we configure it to write to Thanos. And then that's all dynamic. And of course, as I mentioned, we still have to add some label parity here as well. And then basically we just opt into that additional sidecar container. I'll spare you showing the rest of my Terraform, but this is kind of the way that we do this kind of sporadically spin it up and load the configuration. So yeah, so that's kind of like what it looks like end to end, and pretty excited about this, that we were able to maintain continuity for the custom metrics. As I mentioned, we don't think that everyone's going to continue to necessarily need this, but we think that it's been done in a way that is obviously like kind of repeatable and not like a one-off for code suggestions as well. But it's just a problem I think that we had to unfortunately solve a little bit sooner than we would have liked to. But yeah, so that's it. Demo.
Is there any plan to move this just all into .runway.yaml in the repository? So
yes.
if
So you mean like the sidecar?
The way that the end user, so the people who want to deploy an application, opt into the whole thing. Like, yes, I want the sidecar. Can I just set a flag, maybe a port,
Yes.
maybe an endpoint to?
So this is what this would look like. This
okay.
is the runway YAML. So like this, some parts were omitted, but this is where you would typically say, you know, registry.myimage, you know, whatever. This and then obviously the interface is going to change. Maybe it'll just be like custom metrics or something like that, some flag. But yeah, we would say, give us the list of where you essentially want us to A, spin up the sidecar container and B, start scraping it.
Yeah. So as soon as observability
remote write it. Yeah.
As soon as the observability thing is there, we might decide to include the Prometheus agent, and
that's exactly what we're doing. Yeah.
But that config lives out of the hands of the end user and in that.
Okay, yeah. So the configuration, the reason that the configuration is not like, so I guess to reiterate, it's like it provide like a values file or something like that. The reason that this doesn't exist is we just take the runway, at least in its current iteration, we're just taking the runway YAML for a way to opt in, and then we're dynamically configure, because then we know all the other metadata, like we know your service name, so we can populate the labels. And we also have to deal with secret management because Thanos tenant credentials are secrets, so we have to fetch those. So we obviously wouldn't want those. So we're not like exposing the raw Prometheus.yaml file. It's like an abstraction to say, tell us where you want us to scrape. We'll embed that metadata into the config. We'll generate the config for you. We'll spin the sidecar up. It's all like automated, super frictionless for you. Another kind of reason, just not limited to secret management, but we wouldn't want to expose it. It's just because, like as I mentioned, it doesn't have the full feature set. So if I tried to put in like some alert, if I tried to enable alerting with this config, the agent like quite literally won't start. You know, we wouldn't really want to expose this anyways because it's a smaller feature set of the Prometheus configuration.
That's great. Thank you.
Quick question. That's really cool, by the way. I love that. Love that solution. I had no idea like Cloud Run could have sidecar containers. That's dope.
Oh, we beat it to submission.
It's really, really cool. The only thing that I'm thinking about is, I think you're definitely right not using a push gateway, but I think that maybe I'm misunderstanding Cloud Run, but I did just do a quick Google right now. But like, aren't Cloud Run containers like inherently like time span limited? So there's going to be a period of time where like you're going to miss metrics off the end of your thing, right? Is my understanding?
Yeah,
right
no.
there?
So my understanding, that's a good question. So if we don't, I think we basically have solved this by running a minimum number of instances, because if we don't, the cold start for the containers are too long. And so if no one does code suggestions, they try to hit it, it could take up to like 15 seconds to load or something. So that's kind of the solution, is I think to essentially have a minimum number of instances running. Does that answer the question?
Yeah, I was just thinking like just in the specifics of, I mean, I guess it does. Like, I was just thinking like, you know, because obviously if like an instance, they have like a lifetime, right? Like a Cloud Run instance. So like if you're scraping, like there's going to be a period of time at the end of its lifetime where you're going to miss off some number of metrics, right?
Yeah, so I don't know the entire specifics of the way that the batching mechanisms work, but my my understanding is that it's intended to drain them to the remote right before to essentially batch off any final requests before the container is spun down.
Okay,
Can
yeah,
we-
cool. I was just curious.
We stop requests to a Cloud Run container like 30 seconds before we shut it down? Or is there an option for something like that? Because that would give you that, presumably it would give you that, like, you know, final pushes, and then you wouldn't miss them. But I don't know if that's an option or not, but I'm just thinking out loud.
Yeah, yeah, I've done that. I found out the hard way. We had to, of course, do kind of the startup probe because it takes a little bit to start up the container, and then a liveness check as well. And those were kind of like the available primitives that were within the Cloud Run. Again, we're kind of, that's our main constraint there, is working within like what's available within the Cloud Run API.
Okay. I think my question's not directly related, but I think there's like an overlap. But this might be, sorry, I was kind of multitasking a little bit at the beginning, and I might have missed something on this. But with Push Gateway, like one of the things that kind of the unexpected complexities of Push Gateway for me is that, like, if you have one thing pushing a metric and then another thing pushing that metric, they'll like overwrite one another unless they're like the series are made to be unique. And with this, right, presumably you're going to have the same problem. Like if you are pushing, or does Thanos add the uniqueness on its side? No, each container doesn't get a unique username and password. So on the Thanos side, they're all coming in from the same. But I guess my question is, if you have two containers that are running in Cloud Run concurrently, and each one is writing, you know, the same metric, how do you make those unique?
Yeah, that's a really good question. So at this point, we have not dug into the concerns that are raised there. So we have two concerns. So the first is the scenario that you've highlighted there of possibly inaccuracies. And the second kind of concern is just the performance characteristics of this sidecar container. Like we don't know how much resources it's going to use over time, et cetera, as well. And don't really have an answer to that right now, but this is kind of our concerted effort to say, hey, we've tried to get these custom metrics in, and this is like the only solution that we could really make without the dashboards going to zero. And if there are data discrepancies or inaccuracies, then of course we wouldn't have to go with this experiment.
Like a
with remote, right? You've got the published labels, the external labels, whatever they're called, to add. And like, since you've got the config for the Prometheus agent there, and that's entirely in the control of Runway, that's what can make your...
Yeah, so you could put like a container ID or something label onto the metrics that you're sending. That would be what I would guess with that.
Yeah.
Doesn't Prometheus, like, are you talking about the same container within the Runway app? Like multiple containers within the
multiple instances of the Runway pod. That's a better description of it, right? Yeah. So the pod, it's got the remote writes, it's got the application, and say there's 3 of those running, and they're all saying, you know, the one is saying HTTP request counts 1, and the next one's saying 0, and then the number, you know, each time it writes, it's switching between 1 and 0, unless you have another unique
something to make it
container
unique.
ID or something. You know, like if you look at our pods in Kubernetes, we use container ID or pod ID. I think, I can't remember, but basically it's actually pod ID to kind of differentiate them so that those are unique, right? And so we'd have to have something like that, I think.
Do we have a sidecar for each of those instances, or do we have one sidecar, one TDA?
That's where my misunderstanding is coming from. Because surely you need one per. Is there one sidecar? Well, a sidecar surely is per pod, right? Or per...
So there's one sidecar, and it's per ingress container as well. So
okay,
yeah,
so,
let me.
Yeah. Sorry for that. Yeah.
No. So I think I have this pulled up. Yeah. So this is this is, I think, so yeah, the containers list is ingress container, and then the Prometheus agent container as well.
Yeah. But of this, right, there can be like 100 instances of this of this Cloud Run, right? That max instances there can be 100. And so my understanding is that there will be 100 of the Prometheus agent containers, one per application that's scaled. At the moment, yeah. So, if you get to concurrency 80, then the 81st concurrent request will spawn a second container. And then that one will have its own remote write, as I understand it. And that's where we'll need to have some sort of distinguish.
Yeah, that's a great point. Yeah, that sounds like a
Yeah.
reproducible solution. So we can take a look at that.
What I'd do is
try to
set the
validate.
concurrency really low, like make it 2, and then you can quickly scale up the number of pods, and you'll see what the behavior looks like quite quickly. So if you change that concurrency to 80 down to like 2, then you can easily get a second pod starting up. Awesome, but I'm happy to look at it some more. I might also be misunderstanding how it works.
Back to the concern that Calliope brought up. So I haven't looked into this too deep, but like my understanding is that Cloud Run determines if a container is idle when it's not serving requests, but does serving requests means only the application port, or does scraping for metrics also makes Cloud Run consider that container alive? Do you know?
But that's not ingress, I think.
It's only ingress that Cloud Run considers for liveness.
And that was my understanding, but I don't know chance.
You mean for the liveness of the container or serving requests? I'm not sure.
Yeah.
I follow.
Yeah, no, like my question, maybe this doesn't follow, but like my question is when a container hasn't been taking client requests for a while, Cloud Run will consider it idle, and then at some point we'll start shutting it down. And then what I was wondering was, does Prometheus scrape requests make Cloud Run consider it live again? But
Oh yeah, so I want to say it doesn't, because I believe the criteria for that is the requests coming over 8080, which we're not scraping. So I think that would continue to happen in the background without impacting the criteria there. That answers the question.
okay.
I think there's a diagram in the docs that say that essentially, like, the requests come in, it hits ingress container.
I just dropped Google's kind of, it's not a technical documentation piece, but it's an article walkthrough of the lifecycle of containers on Cloud Run, which I think does a relatively good job at doing an approximation of what happens in the doc.
Cool. I think if there's no other questions, next item.
Sorry, one last
sorry.
thing. Can you just quickly drop a link to and this is probably like a really obvious question, but I'd just like to see how that's kind of implemented on Runway's side. Have you got a link to the?
Yeah, I'll link to the draft MR and some relevant issues. Yeah.
Amazing, you're the best. All right.
Cool. I guess it's me next, since Bob volunteered me to do a demo. Thanks, Bob. Bob's like, no, it was totally not me. So I've opened a whole bunch of links. I'm going to inflict my Thanos docs pages on you. And I'm going to share this and walk you through really quickly the only thing that Matt and Bob and I do with our lives at this point in time. Can you see the giant Chrome window? Cool. So for those who are not following along as much with this, I'm going to talk to you about what the issue is, how we're trying to fix it, and then a lot of math. Cool. So to start with, why is this a problem? This is the actual epic in question that we're working on. And the reason that it is a problem is, one, recording rules time out regularly, causing gaps in the metrics. This issue, by the way, is over a year old, and Andrew opened and commented all over it in the first place. So I just found the oldest one I could find on the question. It's gotten better. We've done a bunch of work iteratively towards fixing this, but we're still not at 100%. We still see gaps in particularly high cardinality metrics, particularly during prime time. The other issue, and the one that is what we're focusing on right now, is ratio metrics. Ratio measurements are currently accurate to only 2 or 3 decimal places and often report inaccurate results over 100% availability. So we have one Giddily graph from last week that shows both of these issues. Here's the aptX ratio. You see we've gotten to a very impressive 104% availability. Good work. And also we see some gaps. In general, the gaps are more common during busy times. A lot of the work that we are doing with Nick and I say Nick and the reliability observability team, but in this case, Nick, is towards getting a staging set up that we can actually confirm that this will be fixed by a combination of eliminating and cleaning up some recording rules we don't need and setting up sharded ruler. So that is work in progress. And hopefully we'll have some more data about the gap parts in the next couple of weeks. But for now, I'm going to go to this problem number 2 here, which is this issue. So I've opened a lot. I've opened all of these screenshots so you can see them higher. But at a really high level, this is where it gets into complicated math bits. What we do in order to calculate aptX is we run a query for the numerator, which is requests that we consider successful. There's a slightly complicated piece of math around satisfied and tolerated. I'm not going to talk about that. That part works fine. And we store it in a recording rule. And then we separately run a query for the denominator, which is essentially the total requests. We store that in a separate recording rule. We take those 2 numbers, we divide them, and we get the aptX. Problem is, I think we've fairly well confirmed this. We're not getting these scrapes close enough together for things that change regularly for them to be accurate to the number of digits of precision that we need. So if we look at, again, we're doing a lot of work with Giddily, so there's going to be a lot of Giddily related graphs here. I've got some web ones as well. But if we look at these 3 graphs here, this is the calculated aptX for Giddily. You see the random crazy, this is only 100.5, so slightly better. This is the same aptX calculation taken only from the raw metrics. So this is going out and doing the very complicated Giddily aptX query on raw metrics. And as you can see, not only do these not match, they're not even the same shape. And this is the same thing done again for web. Here's the service aptX for web this is Canary and main. And here's the raw metrics calculation. These are closer, but we still see things like this big dip here at 1745 that isn't on this at all. Cool. I'm not looking at the chat, so keep saying wow as much as you'd like, Andrew, because it gets better, worse, different.
Stephanie, when you're done with this demo, I've got a little bit to tack on to the end where
cool.
I've got some raw values.
Okay, so we looked at generally where we're at as far as number accuracy, and we generally get 3 nines worth of accuracy for all of this, meaning when we say 99.9% of the success succeed, they really do. When we say 99.95% of the success succeed, that could or could not be true. That is different with everyone. So what Bob and Matt and I have been doing for approximately the past week is creating 80 million experiments in which we are looking at web and GitLab predominantly and creating experimental recording rules to determine what the correct way is to fix this. We have created a recording rule that just does this raw metric calculation and records it. We have created recording rules that continue to do the intermediate calculations and divide them. And we found some interesting, I think those are pretty much the same, like the thing that we ended up finding out was some really interesting pieces around offsets. So this is web, and this is web from yesterday. We have there's about 100 of these Thanos query links in this thing. So I'm just going to walk you through quickly what we're saying here. So this first one is the recorded apdex. It is what we are saying now. It is what we are reporting, the end. We also have what we are considering. Does this one actually have something called control? No. Cool. Why would I pick let me actually switch a second and go to one that Bob did with all of his nice pieces. So I'm going to start with GitLab instead of web, because that's what we've been looking at so far. So again, here we have, this is what we are recording now. We have the 1 hour raw metrics, which again, we see that we are in, we have unfortunately very different graphs. There we go. Oh no, hold on. Let me add these in one by one. So you see that again, when we look at the raw metrics versus the recorded rule, they're not, the rough shape is the same, the spikes are not. Here's where things start getting weird. We started thinking, okay, if we need to get the same scrape, perhaps we need to add an offset and make these delayed by some period of time so that we could get closer. If we start adding in, this was our first offset 1 minute. Well, let's take out the control. These look similar-ish. Hold on, let me get this right. But not completely. We still see some slightly different shapes. We added in every variety of offset that you could humanly imagine. Let's take out the 15 minutes. So 5 seconds, 30 seconds, 1 minute. They're all pretty much like, we shift in time because each of these are going to add a delay to the calculation at different levels. We also went through and said, okay, let's create, and this is the one I don't have here that is as interesting. I'll do this on the other one. Let's create the same intermediate recording rules that we did as before. And let's add the same thing. And you see that those.
Just to interrupt a little bit, when Stephanie mentions intermediate recording rules here, she means the apdex numerator and the numerator separately. We also have intermediate recording rules even before that. So this problem
that is correct.
Is exaggerated when we look at web metrics, for example. GitLab doesn't suffer from this. Sorry, continue.
Right. No, please. So in this case, the ones that are called double offset, I'm going to show you why that's a thing in just a second. But these are essentially intermediate recording rules with offsets of 1 minute and 30 seconds. We start seeing again that we're getting, the shape looks similar. Here's where one of the most interesting one came. So this is from yesterday. And this is where one of the things that, of the many pieces of this that have confused me, this one confused me the most. So we have this recording rule right here. This is a recording rule that essentially just does the 2 intermediate rules and 2 intermediate rules. So we're doing query for the denominator, or query for the numerator with a 1 minute offset, query for the denominator with a 1 minute offset, do the calculation, and this is what you get. It's not even slightly right.
It looks terrible, but it looks better than what we currently record.
That's correct. Here, let me put the, well, in this case, it actually doesn't because this is web. Web is, this one for web was really bad.
So just because Stephanie's leading up to the double offset, I want to clarify that the numerator recording rule has an offset of 1 minute. And the denominator recording rule likewise has an offset of 1 minute, but the ratio that we report as aptX, which is literally just the recorded numerator divided by the recorded denominator, neither of those has an additional offset yet.
Yes.
It's easier if you can see the formulas, but they're kind of nasty looking, so that's why she's just describing it verbally.
And especially with Giddily, they're a level of nasty looking that will make your head explode. So
yes.
I will put, or maybe one of Matt or Bob can put like the link to the runbooks file in the issue.
I'll do that.
Or sorry, in the demo. So we saw this and we said, well, that doesn't make any sense. So we added an offset to this, to both the numerator and the denominator, or like, so we're doing this. We say, give me 1 minute delay numerator, 1 minute delay denominator, and then take both of those and do an offset of 1 minute and calculate and do that math. And this works. Sort of. I guess the question is, how many more hours do we want to talk about this? So let me start with, before I ask maybe if Matt wants to show the thing yesterday, if not, I can open.
Yeah, I've got fresh data I want to share.
Cool. Okay. So this is really interesting, and we get to a slightly more accurate number, but we're still in strong experiment phase. So Matt, do you want to talk about the numerator and like the difference that you saw? I can stop sharing.
Yeah, sure. So
and does anyone have any questions first? I don't. Okay.
All right. This is dense stuff, so don't be bashful. We'll also do like a summary roundup once we've got all our ducks in a row. Okay. So yeah, Stephanie and I were talking about this yesterday, about how while it's still fresh in our heads, we need to write this all down. Okay, so I'm going to walk you through a little trick. In case you didn't know, because I didn't know this for a couple of years, for a metric like this, you're familiar with using this range interval expression when you're going to do a computation like rate, for example. But you can also, if you don't pass this into a function, you can get the raw values, and that's what we're looking at here. So these are, I'm pinning, so all three of these Thanos graphs that we're going to look at, they're all pinned to the same exact moment in time. They're all using the same 5 minute range that we want to see. So this is giving us all of the raw values for the 5 minutes ending at this moment in time. And I'm going to just take a moment to hide the zoom widget. And the format of the output is, this is the raw value, and this is the Unix epoch timestamp down to a millisecond precision. And you'll notice that the millisecond precision is fixed for all of these, and they're all incrementing by exactly 60 seconds each time. And that is because our recording rule specifies an interval of 1 minute. So it will choose a timestamp for that particular aggregation group, and continue to use that at 60-second intervals, apparently with no variation whatsoever, down to the millisecond level of detail, which I don't quite understand yet. But we're going to take that as it comes.
The only way they must be pinning it at the beginning of the
Yes.
run. That's the only way that could possibly happen. But that's news to me. I didn't know about that. That's super useful.
Which is
Yes.
lovely because, as Matt will show.
Yes, this may actually have a semantic impact. I'm not entirely sure yet. So hold that thought of what timestamp are we really using as when we choose which inputs we're going to get. So like Stephanie was just talking about, this is literally the recorded numerator divided by the recorded denominator, each of which has an offset of 1 minute. So since we're looking at the raw values here, what we're going to do manually in the spreadsheet I'm about to switch to is I've copied all of these raw values, and you can see that we missed a record for the numerator, but not for on one of the Thanos rulers. I forgot to highlight. We've got two output sets here because I've turned off deduplication, so we can see all of the raw values. This one's from Thanos ruler 0, and this one's from Thanos ruler 1. Same story for all three of these outputs. So what I've done here is I've copied the raw values into this spreadsheet. I added a placeholder for the missing one. So these are all horizontally aligned to the same time. Here, here, and here. And we've got all the little Thanos ruler zeros up here and the ones down here. So what we're going to do here is recalculate the apdex ratio from its inputs, which is the numerator and denominator, from one recording interval backwards. So we don't get a value. So this is our recomputed one. So this is this takes inputs from this divided by this, and the result here exactly matches here because this column is just subtracting those two columns, so we can see which ones don't match. Does that make sense so far? And this is just summarizing the formula that we're using. This is one interval backwards for the numerator, one interval backwards for the denominator. So that matches here. It matches here. It can't match here because we were missing a value. So we have to do something interesting. And Thanos wants to produce something in its recording rules. So what it really ends up doing is picking the nearest available metric. So if we go to the previous one, yes, that's exactly what it did. So that's why we've got an I-2 here in our kind of noted formula. So you can see that matches now. Great. So what's going on here? This one also doesn't match, and it's not missing a data point. So it turns out that for some reason, it also was using a numerator from the previous, so from 2 intervals ago, and the denominator from 1 interval ago, and this is not semantically correct. This is effectively looking at the rate from a different time, from a completely different non-overlapping time span in the numerator versus the denominator, which is why this is one of the significant sources of error for our apdex dips and spikes. And you can see here, I don't know if the font is big enough for you to see, but this was the lowest recorded value that we had for apdex. And it's because of this. It could just as easily have been a spike but this is a source of noise. It's a source of errors, and we get the same error here, but we can at least kind of justify it because the system is compensating for missing data. It's not compensating correctly. It would have been correct if it had gone the same number of intervals backwards for both the numerator and the denominator. But Thanos doesn't know anything about what we're trying to do. It doesn't understand that we need symmetry in terms of it matters more that we're looking at samples that came from the same era of time. And as far as I know, there's no support for that.
And era here is 1 minute, so yes.
And so this is this is kind of a concrete example from the best that we've got so far of using intermediate rules where taking a step backwards, the whole reason that we introduced a small offset, and it doesn't necessarily have to be a whole 1 minute offset, by the way, that was just where we started. We've seen similarly good results with offsets as short as I think 5 seconds was the shortest one that we used. So we can talk about the theory behind that later, which we're a little fuzzy on, but we have a couple of
what we've currently glossed over. Like now, this is the new problem that we're solving. What we've already glossed over now is the problem with scrapes, and that's why we introduced the first offset. This offset that we're now talking about is about the recording rules. And this is new to me.
Yes, yeah. This is hot off the presses. This is what I did this morning right before this meeting. So yeah, that was the new bits I wanted to share. So I guess the interesting takeaways from my perspective are we can look at the raw metrics. When the recording rule is doing like the recording rule for web to calculate the recording rule for the numerator for web and the denominator for web would be just intractably difficult for us humans to do because it would be aggregating many, many, many data series, like hundreds or thousands of series. But I wanted to try this for the aptX calculation because it literally takes one series for the numerator and one series for the denominator and just divides them. So it's very simple for us to repeat that calculation and this is and get a sense of where the defect is. This is a generic problem for ratio calculations throughout. It's a generic problem for ratio calculations that take recording rules as inputs. There is no guarantee that the same time span is used for the numerator's samples versus the denominator samples.
One extra tidbit of information that I want to add here is that the numerator, denominator, and the ratio are all recorded in the same group, like in the same recording rule group, and the ratio is recorded after we've recorded the two other values. So the assumption that the third recording rule could use the two previous values was not correct.
Yes, it apparently based on this 5-minute sample, it did so 4 out of 5 times, but not one of those 5 times.
Yeah,
and I think it's worthwhile to very briefly note that the reason that we're using all of these intermediate recording rules isn't just that we want to make everything really complicated. It's that it is a performance. Like it significantly improves the performance of how all of this works to a point that not using them may have scaling implications for the future. We just don't have an answer for what that is. Like
I think we can use more, like we can get closer to the sources we've proven, but some things, in my last comment on the issue, I mentioned that we do like augmenting the data and removing parts of the data.
Yeah.
When going from one aggregation set, which is a collection of recording rules, to another one. And like if we can't record all of our aggregations from source metrics because then like there's not enough Thanos ruler in the world to do that.
Yeah. So I guess as kind of a wrap up summary, this is decidedly work in progress. I mean, as noted, Matt has come up with more details on this since I talked to him at 4 o'clock yesterday.
Yeah.
Like
Stephanie and I were speculating about this, and this is the hard data to confirm our speculation.
So there is an issue. It's linked there. It is very dense with data. When we have an answer for what all of this is, and we've like stopped the experiments and we've come up to a thing, we will totally tell you all what it is. You do not have to read that issue.
I think we can already mention one thing that I think agreed upon. When we record source metrics, anything from source metrics, we will add an offset. We don't know what the offset is going to be yet, but that will make it so that we are sure that all of the data for that moment in time isn't going to change anymore. Sometimes when we record now without an offset, it might be that the scrape or whatever data that we were recording at that moment was still missing something. So a slight offset fixes that. This is the first part that we've solved.
Yeah, and that fix alone may be worth merging into the existing recording rules. We've been talking about that for a couple of days.
Yeah, we're gonna like the focus is to get both an end accurate aptX calculation, but if there are things that we can iterate on that will make what we have today more accurate, we will totally do that.
And like Bob and Stephanie were saying, this is the using a small offset is avoiding a plethora of race conditions where we're trying to query data that's freshly arriving. And if we can just bypass that race by showing up a little bit late to the party, it's absolutely worth it to gain a whole significant digit of accuracy.
Yeah, and I can tell you that even like 5 seconds appears to potentially be enough.
Also,
that was yesterday's experiment.
Out that like if we like part of the exercise that we're doing is what if we move all the recording rules to Thanos, then we don't need to have intermediate rules in Prometheus that then later get aggregated again in Thanos. Adding this one, like currently we've sometimes observed several minutes of delay in metrics because we have chains of recording rules. If we only chain 1 or 2 levels, then we will only add 1 or 2 minutes or one.
Could be seconds.
Yeah, could be seconds. Could like but we'll know how much delay we introduce. And we think that this is more acceptable than what we're seeing now.
I think it'll also be a lot less cognitively expensive. Like, because at the
Yes.
moment it's like, okay, so there's this loop and it's doing this, and then there's this loop and it's like, it'll be so, it's like, well, we just record the recording rules and we get a result. And that's like so much easier to understand.
Yeah.
I won't need to get a cup of coffee to figure out what in the world this metric is trying to tell me.
Matt and I, while Bob was on vacation, went through all of the Apdex things all the way down to the like lowest level of JSON, and I think it was useful work, but it did take both of us 2 days. Like, so the easier we can make this for the people on call, the better everyone's lives will be. And one piece of this project, which I didn't actually mention, is like actually document very, very clearly how all of this is put together. Which is, of course, a work in progress, but the more ease that we have to understand this at every level, the better it will be.
So I think the first step of this is going to be, the first step, like completed step, is going to be of the move of metrics into tunnels is going to have the component SLIs, the shard SLIs, the node SLIs, the feature category SLIs, all record from source, including their ratios. This is what we use for alerting. I think we will have much less noisier alerts, which means happier SREs, which means, yeah, so that's good. And then what we're still now thinking about is how are we going to aggregate that into other aggregation sets. Like those are all source things that come from source metrics. I hope, like, we still need to check if we can actually scale tunnels fluid enough to do that, but assuming we can, we'll do that. And then the aggregations where we actually filter or add data, this is what we're thinking about now. Like, yeah.
Yep, and it's definitely worth calling out that the fact that I went to Nick maybe a month ago and was like, hey, we really need a thinner staging environment, and like now, and one has more or less almost completely appeared, is probably one of the only things that's going to get us through all of this, because we need to have a place that we can go and potentially trash a bunch of recording rules that don't impact, you know, the people who are on call. And we can actually test performance, and we can test all of these 80 million things that are questions. So like, huge thanks to Nick. Huge thanks to Dave for letting us have Nick to do this. Like this will make everything so much easier for now and for the future.
Thanks for feedback. Good to hear.
Yeah, I think also there's going to be a lot less of those, whoops, I just set off some terrible alert because I made a change that I couldn't possibly comprehend, which we've all done. I've done a lot.
There's so much, if this all works, there's so much of the JSON we can remove. We can remove the what's it called, the recording rule registry.
Yeah.
We can yeah, there's a lot we can remove it.
So just on that, for the component ones, like I could see us just removing them all. For the other ones, like the service one, do we like still just use the component ones? And
no,
we don't know the service one, so we don't.
That's the one
we
I mentioned.
Those, they would be insanely big queries.
Yeah.
Right?
Yes.
Like all the components would like recompose.
That's the ones that I mentioned. That's what we're still working on now. So everything that is coming from source metrics, basically the component, shard, node, regional things, feature category ones, those can come straight from source metrics. And then we've got the stage group ones, the service ones. Those are like enriched with filters and
and in some cases are multiple Apdex aggregated together for different components for the service one. Conveniently, web and Gitly are only a single component, which may be why those are the ones we're looking at. But there are many others who are not.
So those are still going to be a recording rule chain, kind of. So one aggregation set into the other one, because otherwise,
But we
But
also
those
like
generally going over a longer time. They're not like, so it should be okay, I imagine. But
and I also think the thing that really matters more for this is not necessarily how accurate they are, but that we know how accurate they are. Meaning, if we know that it's like we've got 5 total digits of accuracy, cool, then we just won't care about anything more than that. But if we are like we are today, where we're like, I don't know, error
it's
budgets are
variable.
wrong.
For those
Yeah.
for those specific aggregation sets, well, the service one we need to talk about, but for those specific aggregation sets, they are not used for alerts or anything.
Yeah.
So we care about accuracy. They are used for error budget for stage groups and for service level availability of GitLab.com. So we care about accuracy more than we do about speed or
But we could also do them much over much longer periods of time and let them take longer to run.
We need to do them in less than, we need to do them at least every 5 minutes. Andrew, correct me if I'm wrong.
So I wouldn't hold too much weight on the SLA calculations because I think that we need to completely redo them from.
Help me. I've said the same thing to Alan today.
Yeah, I think we need to completely redo them from Cloudflare logs, right? Because for a whole bunch of reasons, because recording them inside the application is really silly, because when the application goes down, the SLAs there's no traffic. So it's all happy days, which is ridiculous and makes customers very angry. But also, if we do it at Cloudflare from logs, then we can start looking at per customer, where we can say your availability impact from this was X, which is and we Cloudflare is a good source of truth. We can say your request did not get through, and it's but that's a whole. All I'm saying, in that discussion is not even started yet. But I just don't think we should be worrying too much about that SLA calculation because it's well overdue, a review. I think
that's one part of it. The other part of it is the current way that we do SLA calculations is time slice based, and everything else that we do is occurrence based, dedicated error budgets, all the rest. So, but that's a conversation for the future.
There's been a lot of backwards and forwards on that one.
I'm aware. I've read so much on all of this. So
because it's a big one.
So that's it. I mean, that's this giant thing that we're working on. We're gonna come up with an answer. We're not there yet. That's kind of the summary.
If you have the link from yesterday or the day before yesterday where you were showing, if you have the link where we had mismatched scrapes handy, that would be cool to show, the raw metrics. If you have that handy still, that would be cool. And otherwise, I think we can stop it.
Is that, let me screen share. I'm not entirely sure. I guess we don't have to stay on for this, I guess, but is this what you were thinking of, or was it something else?
No, it was the numerator and denominator.
Okay.
A specific timestamp. I don't know how you were doing it.
I suspect it was the blink one.
Yeah. So this is okay. So this is just for funsies. There is a so I love cosmology and astronomy, and one of the things I just got so psyched about as a kid was this tool that people would use called a blink comparator, and this was effectively taking it was a machine that would show you 2 photographic plates of the same region of sky, and you would toggle a manual switch to switch between them, and this would let you this would let you find things like variable stars or asteroids. Because you'd see tiny changes, and you had to have good eyesight. So this is my blink comparator redux, where we're toggling between these two graphs. This is the numerator, and this is the denominator, and they should be. This is specifically looking at the noise in the numerator calculation versus the denominator calculation. And we're doing that by comparing the recording rule output versus the repeating that query manually now. It's big. But yeah, this is the recording rule, and this is what was the query that was being recorded, and we're subtracting them so we can see that it should converge towards 0. Like a perfect outcome would be all zeros here. And this is letting us quantify how much noise there is in the signal. And we can see that the numerator and denominator have a few points where we're either missing data in one and not the other. Like here, we're missing a value for the denominator and not the numerator. And then we've got interesting places like here where they're just different values. And this resulted in, this one in particular, this 1244 mark, is one of the places where we had a huge dip in our otherwise great apdex calculation, and the reason for that is what we were just looking through on the spreadsheet back there. Oops. Well, anyway, yeah. So is this what you were thinking of, Bob? Or did
No, I was. This is also super cool. So thanks for showing us. But no, it wasn't what I was thinking about. I was thinking about the place where you showed that different data points were available for less data points were available for a scrape. So we had, and that's the first level of offset.
Yeah. Okay, I'll see if I can dig that up.
But yeah, that doesn't have to be on the call.
Okay, cool.
So yeah, I essentially at this point in time link this issue every single day when I do a scalability write-up, because that's all we do. So follow along if you'd like. I'm certain that we can talk about more of what we found in 2 weeks when this demo comes back to a time zone that I can attend. Bob's welcome to talk otherwise. I just don't like you enough to show up at 4 o'clock in the morning. Sorry. Cool, I think we can be done then, right?
Yeah. Thanks, everyone.
Thank you, that was awesome.
Yeah.
Bye.